Hello, geometers. This is Miss Backfish, and today in geometry we were working on finding missing side lengths of right triangles using sine, cosine, and tangent, or right triangle trig. We did several examples. We did this whole page of examples and a couple of others, and these were the last two on the page, and we didn't quite get to before the bell rang in second period at least. Maybe we will get to them in seventh. Let me see if I can focus this just a little bit better. It's entirely possible the answer is no. But I wanted to go over these with you. There we go. I wanted to go over these with you and also help you set up some of the next few that you are doing for homework. So let's look at that. First thing I'm going to look at here is determining which side is my opposite, which is my adjacent, and which is the hypotenuse. So what I like to do is sort of trace both sides of the angle and say my two sides of the angle, because we only use the acute angles in a right triangle, will always be the hypotenuse and the adjacent. So if I can figure out which one is the hypotenuse, remember that the legs meet at the right angle, so the hypotenuse is across through the middle of the triangle from the right angle, opposite side of the triangle. This is the hypotenuse. So if I know that my angle always has two sides and one is the hypotenuse and the other is the adjacent, then I can identify the 20 as the adjacent. And then the only thing that's left is opposite. So x has to be the opposite side. Okay. Next, I'm thinking about sine, cosine, and tangent, and which one deals with opposite and adjacent. Why opposite and adjacent? Well, because I need to find the opposite, and I already know the adjacent. So those are the two sides I'm working with. The hypotenuse, I don't have any information about, and I don't need any information about. I'm not being asked about it. So I'm working with opposite and adjacent. Okay? And when we look at our trig functions, basically it looks like this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So in this case, I'm going to use tangent. And so tangent of my angle, tan 72, it's always of an angle, equals opposite over adjacent. That's my equation I'm looking for first when I look at your work. All right. Then I'm going to cross multiply. I think of that as being over 1. And so tan 72 gets multiplied times 20 and x times 1. I always write the 20 out front. 20 times or the number out in front of the tan. The reason why is if I wrote it behind there, I wouldn't want anyone to get confused to think that the 72 was multiplying times the 20 before I take the tan of it. Okay, so I like to put it out front. So 20 times tan 72 equals x times 1. That gives me x. The next thing I ask myself here is x alone? Is my variable alone, whether it's x or y or theta or whatever? The answer here is yes. If x is alone, it's time to pick up your calculator. If x is not alone, it's not time to pick up your calculator. It would be time to get it alone. You would keep going, which usually means you're going to divide something away from x. But here x is alone, so I'm going to do 20 times tan 72. When x is alone, the other side tells me what to do in the calculator. So if you're ever wondering how do I know when to multiply, when to divide, cross multiply, set up your equation, cross multiply, and then let the equation tell you. Get x alone or get the variable alone, and then the other side tells you whether you're multiplying or dividing. I am multiplying, I get 61.55. I'm rounding to the nearest tenth, so that's going to be 61.6. Always make sure you read the directions to see what you're being asked to round to. Next up, here's my angle, 54. It has two sides. One of those sides will be the hypotenuse, and one of them will be the adjacent. That's always true. So this is the hypotenuse. It's across from the right angle. So this must be the adjacent. And that means this is the opposite. All right, so this time the two sides I'm working with, I'm not working with opposite at all. I don't need to find it, and nobody gave it to me. I am working with the adjacent because I need to find it, and the hypotenuse because you gave it to me. The problem gave it to me. So looking back up here, the one that deals with adjacent and hypotenuse is the cosine. So that's how I'm going to set my equation up. So I'm going to say, oh, sorry, I need to move my camera here. Hope I didn't make anybody seasick. Cosine of 54 degrees equals adjacent over hypotenuse. There's my equation. Now I'm going to put that over 1 and cross multiply. So the 12 is multiplied times the cosine 54, and the x is multiplied times the 1, so that's just x. Is x alone? Yes, x is alone. So now I'm ready to put it in my calculator. Whatever it says x is equal to. It says x is 12 times cosine 54. So 12 times cosine 54, that gives me 7.05. I'm going to round that to 7.1. Let me point out here, if you're using a scientific calculator, those default to degrees, so you're fine because we're using degrees. My 54-degree angle, it's 54 degrees. If you're using a graphing calculator, sometimes they'll be in radians depending on how you've used them recently. So with a graphing calculator, you always want to go, it has a mode button as well. You go to the mode and check to make sure it says DEG and not RAD. Okay, so we got 7.1 for x. If you're not getting this, if you're typing in the same thing I am and not getting the same thing, that's an indication maybe that your calculator is in radians. All right, looking at the homework is 12 problems that are similar to this. I'm going to zoom out a little bit and show you my finger. There we go. I know I could be doing this more elegantly, but hopefully you're fine with it. I want to pick one that works out a little differently. So I'm going to pick, let's see. How about number 7? Okay, I'm going to skip down to number 7. I suggest you pause the video, think about how to set up number 7, and then just play enough to see the equation and see if you set it up right. All right, me setting up number 7 looks like this. Two sides of this angle. Notice that I could find this angle instead, but I'm always trying to use the angle they gave me so that we'll be doing the same thing for one thing, and also so that I can try the different types of problems they're giving me. All right, so these are my two sides of the angle. This is the hypotenuse because it doesn't touch the right angle. The angle itself is always where the two legs meet in a right triangle. One of the legs we call opposite and one we call adjacent. The two sides of my angle are always hypotenuse and adjacent. So this is the adjacent. That makes this the opposite. I'm not working with the adjacent here. I'm working with the opposite because it was given to me, and the hypotenuse because I'm trying to find it. Opposite and hypotenuse are sines. Okay? If you didn't write down what I did earlier here, because I can't really refer back to it very easily, where I gave you those 3, you might want to go back, write them down, and have them sort of on the side as we're working with it. Okay, so sine is what I'm going to use. So sine of 38 degrees equals 15 over z. Make sure you got your equation like that. Pause and go on. So our next step is going to be to cross multiply. And when we're doing that, we finish this up as a proportion and we cross multiply. Z times sine of z times sine of 38 equals 15 times 1. So again, that question is my variable alone? And the answer here is no. So I have to get it alone, which means these are multiplied. To get rid of it, I divide. And I'm sorry I'm running out of space here. That cancels. Now z is alone. And over here I have 15 divided by sine of 38. So that tells me how to get z, is I'm going to divide 15 by sine of 38. And I get 24.36. We're going to call that 24.4. So z is 24.4. Don't forget, you can always check to see if your answers sort of make sense by thinking about things like the hypotenuse has to be the longest side, so it does make sense that 24.4 is bigger than 15. And also, angles and sides across from them are always sort of related in terms of size. For instance, here, this is 38 degrees. These two angles have to add up to 90, so that means this angle up here would be 52 degrees. All right, the 38 degrees is across from a 15. So if I were to find this side, I would expect it to be bigger than 15 because 52 is bigger than 38. Larger side is across from larger angle. Smaller side is across from smaller angle. So those are the types of things you can think about to see, does this answer make sense? I would say I generally don't necessarily check that on every problem, but if an answer seems much larger or much smaller than the numbers I've been using to get it, I don't know, that's not much larger, but 24 is definitely significantly larger than 15. But if I got an answer like 46, I would say, wait a minute, or 100 and something when I've been dealing with 72 and numbers like that. That can just be a way of helping you. So now let's go back up here. This is my students are doing this page for homework. So I'm going to say, go ahead on 1, 2, and 3 and set up your equation. In other words, decide what's opposite, what's adjacent, what's hypotenuse. Actually, you could just do that part first if you'd like. But you could do that and set up the equation. Pause. And now I'm going to show you how they should be labeled in terms of opposite, adjacent, and hypotenuse. This is the opposite. This is the hypotenuse. Here, this is opposite, and this is hypotenuse. And here, this is adjacent, and this is hypotenuse. Okay, so check that you did that right. And then I'm going to set up the equations for you. Okay, so here are my equations for 1, 2, and 3. Opposite and hypotenuse is sine. So sine of 38 degrees equals opposite over hypotenuse. For number 2, same two sides, opposite and hypotenuse. So sine of 26 degrees equals h over 8. And for number 3, we have adjacent and hypotenuse. That would be cosine. So our equation is cosine of 49 degrees equals adjacent over hypotenuse. The next step on all of those is to cross multiply. If you want to pause, you could do that and then come back. All right, now I'm going to show you my cross multiplication. I've got 15 times sine of 38 equals h times 1. Remember, there's a 1 down here. And then I'm ready to put it in my calculator because the h is alone. H times 1 is just h. So 15 times sine 38 gives me 9.234. I'm going to call that 9.2. So h is 9.2. I'm using the squiggly equals because it means approximately. It tells you that I have rounded to get that answer. On number 2, when I cross multiply, I get 8 times sine of 26 equals h times 1. Pause anytime so that you can work ahead of me and see if you're getting it right. H is alone, which is what told me to go ahead and go to the calculator, and I get 3.51, so I'm going to say 3.5. I just told my students, let's round to the nearest tenth on this worksheet. If you were rounding to the nearest hundredth, it would be 3.51. If you were rounding to the nearest thousandth, it would be 3.507. And number 3, cross multiplying. I'm going to come up here because I'm running out of space. When I cross multiply, I get 23 times cosine 49 equals x times 1. X is by itself, so I'm ready to put it in the calculator. Sorry, that messes with my lighting. 23 times cosine 49. Oops, look what I did. I typed cosine twice. 23 times cosine 49. 15.089. So I'm going to round that to 15.1. Let me point out that on each of these, you were only asked to find one missing side. If I was then supposed to find this side, this missing side over here, now I could just use the Pythagorean theorem because I know that this side's 15.1 and this side's 23. Same goes here. You really only have to set up a trig function once in any right triangle problem because from there you could use Pythagorean theorem, or if you're dealing with angles, you could use the fact that these two have to add up to 90 to find whatever else is missing. Okay? I'm going to give you the rest of the key for this worksheet, but I'm going to give it to you in little chunks so that if you want to set things up and then do the equation and then solve, you can do that by pausing. So get ready to pause. So first thing is I'm going to show you opposite, adjacent, or hypotenuse, labeling the sides with respect to the given angle for each one of these. Next, we'll set up the equations. And I'm going to add my little 1 so that I can cross multiply. Here's what I get when I cross multiply. X is alone, so that's why it's time to go type it in my calculator. 37 times cosine 41, and that gives me about 27.9. When I set up the equation for number 5, this is what I get. I'm sorry, that's the equation is here. When I cross multiply for number 5, this is what I get. Y is alone, and so that tells me this is what I do to get Y. So I typed that in my calculator, and when I type that in my calculator, I'm going to get something kind of weird if I'm using one of these multi-view calculators and it's on the math print mode, because it tries to give me simplified radicals when possible. We're not using those here, so just go to this button right above enter, press it, and it changes it to a decimal. So that's 10.2. Okay, then setting up we have our equation for number 6. Let's cross multiply. Here's what we do, what we get when we cross multiply. And because Y is alone, it tells me, okay, this is what you do to get Y. This is what you put in your calculator. Don't go to the calculator until your variable is alone, isolated on one side. So this tells me Y is about 61.4. Okay. I'm just going to go through these really quickly. Pause and restart and restop and all of that. Use it how you will, however this works best for you. Try the problem first though. So this is my opposite, hypotenuse, so I'm going to use sine. I'm going to cross multiply, I get z times sine of 52 equals 18. Is my variable alone? That's a big no. So I'm going to have to get it alone. It's z times sine of 52. I'm adding some paper here so I can have more space. So I'm going to, let me just rewrite it here. It would be hard to write a horizontal line right there. I'm going to have to divide sine of 52, sorry, that looks like an S2, sine of 52 out of both sides. So that now I know that z is 18 divided by sine of 52, and that's what will go in my calculator because z is alone. It's isolated on that side of the equation. 18 divided by sine of 52 is 22.8. So remember, this answers the question, how do I know when to multiply and when to divide? Well, we always set up the equation. We always cross multiply. If the variable is alone, whatever's on the opposite side gets typed in. So if the variable is not alone, we do whatever we have to do to get it alone. And then the equation tells me whether to divide or multiply. Here it tells me to divide. Up here it told me to multiply. So you let the equation tell you which to do. Okay, there's my answer for number 8. Let's look at number 9. There we go. Adjacent, hypotenuse, that would be cosine. Cross multiplying gives me W times cosine 38 equals 23 times 1. Is my variable alone? No. So I have to get it alone. I'm going to divide it out of that side. Dividing both sides by cosine 38 gets W alone. And it also tells me that this is what goes in my calculator. So 23 divided by cosine 38. 29.18, which is about 29.2. Okay, last 3 on the page. I'm not going to explain. I'm just going to give you the answers. So here's your chance to pause if you want to go ahead and try those for yourself without my help. Okay, here are your answers for 10, 11, and 12. Excuse me. And I wanted to show you something about number 11. You might want to pause this while you process whether you got those right or correct your work or whatever. But let me just show you something real quick about 11. 11 is a perfect example of what I was talking about in terms of making sure things make sense. When I do this problem and I get 141, I'm like, what? I was dealing with 15 and 38 and now we're in the 140s? Maybe I did something wrong. Okay, so let's think about this triangle for a second. Here's the triangle I had, and I'm asking whether this side could possibly be 141.8. Well, notice that this angle right here is only 15 degrees. These two angles, the two acute angles of every right triangle, have to add up to 90. So this angle is going to be 90 minus 15. 90 minus 15 is 75. That's a lot bigger than 15. It's actually 5 times as big. So if the 15 goes with, so to speak, across from 38, so in other words, if a side that's across from a 15-degree angle is already 38, a side that's across from an angle 5 times as big as that is definitely going to be much larger than 38. So yeah, it does make sense. Okay? All right, I hope this video has helped you. Thanks for watching, and I'll see you later.